right. I believe I'm streaming. Nice. Well, let me update the title. De-duping intern types. De-duping identical intern. There, that's a more accurate title. Okay, welcome back to the program. This is my first time live, but mostly we're trying to record and put these up on YouTube. So my main quest currently in the language is implementing abilities. These are like Rust traits. These are type classes, and we're somewhat close here. We're focusing really on equals. I haven't done hash yet, but I'm really excited about hash so that we can do a built-in hash table. But equals, impl equals, we've implemented it for string and that works. I was going to implement it for array and I ran into an interesting problem actually that I want to solve. So if we try to run I have a array equality test program. We say missing ability implementation for type 33 array event. So that's its type ID. What's interesting though is we do have an implementation. So I've added some logging here. And this implementation here, ability ID 0 is equals. And we do have an implementation for array event, but we see that actually it's this one. We see the type ID is different. So we have type 28 and type 33. And I ran with dump module, so we can actually look at all of our types. What were the numbers again? 33, 28, and 4. So my types don't actually go up to 33. I don't see array event here. So that's very interesting. Why would the types not all show? There definitely is a type 33. Look into dump module. We have an issue, but the theme of this is going to be even without seeing multiple array ints. I don't see any array int here, so something is up. But we definitely have a lot of array t's. We have oh, this is variables, but yeah, we have a lot of t's, array t's. We have array char twice. These should, what I want to do is when I go to intern these, I want to actually do an equality check and only have one copy, because I want to be able to store the implementations parsed module, typed module implementations. The implementations here for this type for this ability, but that requires that there's only one type array event, right? We can have array event with type 20 and array event with type ID 33. So we want to only intern it once, which is going to save space and stuff. It'll make it a little bit slower to intern a type, but I think you see a type a lot more times than you. Anyway, I don't think the comparison is going to be very expensive. Wow, my dog is freaking out, so I will be right back. That would happen the first time I try to stream. So, all right. Well, let's figure out why we don't see all our types. This does definitely happen at the end. But we are failing to compile, which means something. Let me try. So the program we're compiling is array equality. Let's remove some of the actual checks from it. Just create an array event so that we're going to successfully compile. And I see a lot more types. I'm not really sure how there could possibly be a time that. So here's our last run. Oh, 28 is the highest. Missing ability implementation for 33. This did run with dump module, but I actually don't see the module. Okay, let's re-enable the problem line. Oh, okay, the module's not being dumped for this one. Oh, because we're failing. I see. Okay, so what I did is I scrolled past to a prior command. That's pretty embarrassing. Okay, so when we fail to compile, dump module isn't working. It's actually the time that we most want it. Or maybe it's like dump on fail. So this is what's failing, the run of typed module, which is kind of a clunky way to do it, but this is the type checking phase. So put on a key thingy. Well, let me go ahead and just special case this. So we'll say if letter E we're gonna return E and we'll args. So that's not great, but it's really going to be really helpful. Right, so that's we were using question marks, so we should be able to return that, right? Is this just my IDE being out of date? It is my IDE being out of date. That is frustrating and has actually been happening quite a bit with the JetBrains 2024 IDEs. Just as a PSA. Okay. All right. So now we have a dump. And what I wanted to show was how many array ints we have. So these should all be one type. So that's going to be the goal of this stream. So here in so our type internment is a dead simple vector of type, and the index into that vector is a type ID. No more than that. And here is our type enum. So a pretty simple type system. We have structs, which I called records. They're really structs. I need to rename them. I've learned a little bit since started this project. We have arrays. These are growable, like Rust specs, growable dynamic built-in array. Optional wraps any type in like a Rust style option, but it's a language built-in reference. These will eventually be heap references. For now, they're actually stack references. But the point is it's indirected. Type variables, which is generic, so this never makes it into the physical runtime. Tag instance and then enum. So this don't want to explain right now, and enums are just like Rust enums. These are ADTs, tagged unions with payloads. That's our whole type system. So the type we're talking about here is an array. It's an array, so where element type is equal to the other element type. To do, lose the span. Yeah, I don't think types should have spans. That's true. They do get defined somewhere, so you kind of want them sometimes, but it doesn't quite make sense. So if we just derived eq for this type and used that for our deduping, this actually wouldn't do what we want, because if the location in the source code, so the span of this array event is not the same as the span of this array int, then they wouldn't be equal. So I think we want to implement this ourselves either way. We do want to get rid of the span, I think, on this type. I don't know why this is a to-do. Is anyone using? Yeah, I use it here is the only place in my, but for a lot of other types, I don't actually have spans. So yeah, I just don't think I need it on the type. I have it on the AST node and on the expression, on the type expression that made the type. So let's to-do lose the span. Go ahead, and I hope this won't send us too far down a rabbit hole. And then there was one in CodeGen LLVM. So this will just be span none, which is what I use. I use this, as you can see, in a few other places here in my debug LLVM types. So that shouldn't be a big deal. And let's go ahead and compile that. All right. Good to address it to do. And let's get back to where we were. So we can go look at get type, add type and get type, kind of what we're looking at here. And what I think we just need is we need an equality check here to return the ID. So it's now get or add type, like a real intern pool. So let's write our own function to compare types. And I'm not sure if it can be on type or if it needs to be on module, because it may need to look up other types. So let's start with it on module. So type eq. I don't know. Type 1 and type 2, I think, is fine. And this is going to be a reference. It really is as simple as that. Now, this isn't the same as type checking. This isn't how type checking works. Type checking doesn't check for equal types. It checks if one type satisfies another. So I have a different function for type checking that's a little bit different, or a lot different than just are these the same. It's a little naive in some places and should do more, but this is just are these the same. So I guess we can just match. They have to be, yeah, we can start by, yeah, we can match on the pair, I guess. Is that valid, Rust? Am I crazy? Let's start with what am I doing that doesn't make sense here? Oh. Okay. Unit char int bool string. Whoops. We'll just punt on hard ones. Can't even see that. Record array optional reference. Yeah, that color is really something. So here's the thing. Is it if the type ID of A1 and A2 are the same? Or do I need to like, yeah, so I can rely on the internment having already sort of collapsed identical types to each other. And I think I can just compare the IDs. So these, even though it's called element type, are type IDs. So that's going to cover our test case we just wrote. Now we just need optional reference type variable. Type variable tag instance enum. I don't know what I keep pressing there. Maybe I can watch the recording. My dog doesn't feel well, so he's leaning on my leg. Optionals just contain a type like arrays, so O1 dot inner type, O2 inner type, R1 dot inner type, 2 inner type. For type variables, we'll just say, what all do they have? Identifier ID. So a type variable. I want to be careful. I want to be careful to not collapse type variables that are different but have the same identifier. For now, we'll do false, but this is like a big to do. This is a fine word there. Tag instance. This is actually just if the ident is equal to the other, and these are identifier IDs as well. I do have an intern pool for IDs, and then for enum we compare every field, compare every member kind of. Member. They're not members; they're really variants. And then the record is going to be to do member by member comparison. Okay. How long are we at? 22 minutes. All right. Right, and we'll just say false. And now our fall through case. They were different types, so they're definitely not equal. Not identical anyway. Thank you, Clippy. Okay. I'm not calling my new function yet. 33 array int. We still have 33. We still have a lot of array ints. All right. Let's see what we can do. So fun add type. So we got to walk through all the types in the pool already. And that linear cost is fine because the list will stay so much shorter because we're doing this and keeping it collapsed. So it's a U size, but we're never going to have more than whatever. The U32 max. We're never going to have more than that many types. If we already have it, return it. Otherwise, intern it. The number's a lot lower. Only one array char array int array string. Okay. A lot of t's and a lot of array t's like we were worried about. And then anything that contains, because it sort of recurses down. We didn't recurse, but we're using our prior definition. So an array t is going to have, because there's different t's, there will end up being different array t's. Now, if we ever collapse these t's, then the array t's will be the same. And there are some cases where we do want to do this. It depends on like the scope the type variable's in. But I don't think I have enough information in my type variable type here to know that. And so I think I think this type variable type might need to, unlike any other type, contain either some scope info or point to a variable ID. I think it may need to point to a variable ID. So which knows what scope it's in. Now, why is owner scope optional? Let's just exhaustively check through. Okay, const. Well, actually, that's not true. We do have a root scope now. I think that code is very old. For const. Yeah, okay, great. So you actually, this is eval const, which is, okay, well, I've touched it more recently, but I promise it's old. Before I had a root scope. Okay. I even needed a scope. I added it to 0. We're just going to do it that way. That is how constants work. They're in the root scope. And now struct variable. All right, take me to the errors. Let's record this. QQ to dword WX. Q. Let me run my test suite real quick since I just refactored something. A lot of my tests print stuff, so that's what we're seeing. Test programs printing stuff. Okay. Still only array equality failing. Beautiful. Here are my implementations. Missing ability implementation for 27 array string. But array int is gone. So what I'm doing is I'm actually punting. Notice here, what I'm not doing is impl t equals for any array t. And that would need to be where t implements equals. I don't have any of this. I don't have this type variables here. I do have generics on array, but I don't have that, and I don't have constraints. I have a place for constraints. Here is where trait bounds would go. And so eventually we can do this, but what I'm doing now is I just implemented it for int. I'm cheating. Now, of course, I know this is not how we actually want to do this. For int, we know for a scalar type like this, we know its layout, and we know that we can just mem compare. So my goal is to actually, for all of the built-in scalar types, do an intern here, which is really like intrinsic, which I might change the keyword, which would let me skip the function body and the compiler can implement it. We can implement it ourselves, and we can just do a mem compare. So I kind of want to do that for all the primitive arrays. Instead of course, this is not, now this is necessary for user-defined types because you need to call into the user-defined types equals function. And you don't know if it's just comparing memory. Right? It could be any arbitrary definition of equals. So the generic one, you would want to do this. And then we're going to have the generic one, and then it's going to be competing with the more specific ones, and I would have to resolve it. And so it's really getting to be a lot more than I wanted. So I don't think I'm going to bite this off just yet with the generic definitions here, and but I will go ahead and implement it. What I could do is I could write a generic function equals with a type bound. And then I do have generic functions. I don't have type bounds yet, but if I had type bounds, then instead of writing this code over and over, I could just call it here. My generic equals my, element wise equals with self and other. And at this point, we know the types and it would specialize. So, but for now, let's do, and I'll go ahead and do array string. String equals, this is interesting because this is going to do a lookup of the ability inside the ability implementation for string. But that's not how int equality works. Int equality is built in for now. Okay. So it failed. For array string. Oh. Input equals for array string. Well, that makes me sad. So I still only have 2 impls. Now, did I go out of order? Ah. So this does depend on order. I've achieved order independence in a lot of things so far in the compiler, but this is an interesting one. So what impl equals, sorry for jumping around. So what I had said was I have a declaration pass and an implementation pass, more or less. And I had said, well, obviously, I only need to do this in the implementation pass, the impl. So these, the declaration pass sweeps these up, so we know what equals means, right? So then if someone wanted to implement it above where it's defined, that would work. But interestingly, the implementation of this function depends on the fact that this impl exists. Now, it doesn't depend on its implementation. So in the declaration phase, I need to add a stub implementation. So typed module. So in the declaration phase, I need to add a stub implementation. Which I will have a function ID. It just won't have a body yet. So that it can be looked up when I check, hey, is this ability implemented for string? It'll succeed because it's going to be implemented for string when we evaluate bodies. So big fat to do. So we have eval definition declaration phase. And now we'll get to abilities and ability impls. Fix me. not true, we need to insert stub implementations, skipping the bodies so that we have order independence. Example, I know that string will impl equals after the declaration pass. I need to know, but I do not need to know. Do not need to know the function body of that impl yet. So that I can type check functions that may call equals on string order independently. Okay. Wrong. So we were wrong. That's fun. But that seems like a nice solution. That's correct. That's basically exactly what we do for regular functions. So that makes sense. For now, we'll move it up above. So we impl equals for string before we impl equals for array string. And we compile successfully. Let's remove the dump and let's run the program after we compile. So code 0, that's good. Let's print some things though. So actually, so let's assert that empty is not empty. Assert failed. 3 is not 3. Assert failed. And now let's make these equal to test the array of string impl. Assert failed. So that means our code is being called. Let's look at the LLVM array equality.ll. So equals. I bet you there are quite a few of these. 7 equals functions. Okay. I love that LLVM can just dedupe all these and handle that for you, so you can kind of be sloppy and then worry about the neatness of the IR later. It's really nice. Okay, looking at this though. This looks like string equals because I'm calling it string length and it's a length and a data pointer. Pointer no capture, read only self. Okay, looks like array of what's I don't know. We're comparing the elements. Do we call in array event? This is array event. Yep. And this is probably array of looks like maybe array of string. Looks like, yep, a little bit more going on here. So that'd be array of string equals. Okay. The very first one, I don't know. Equals 6 and 7. So there's actually only 3. This is string equals. No. Well, okay. Whatever. Well, they should be actually in the order. They'll probably be in the order that we did them here. So be array int string array string. And if we get back in here, that is array int. And that is Well, it doesn't really matter. I'm a little bit tired thinking about it. Okay, so that's neat. I think there's still some work to do with uh, typeek here. Of course, we need to implement it for records and enums. And yeah, we need to think about type variables. So if I just checked the idents, what will happen is every time there's a variable called t, when I go to get the ID, when I go to intern it, it's going to say, oh, I already have type T, but it could be in a completely different context. So I think it would be totally busted. Yeah, I think we need the variable ID on it. And then using the variable ID, if the variable IDs are equal, then it's the same one. That wouldn't actually be too bad. How long do I have? I think I have time. Let's try it. Variable ID. And this would mean that they really are the same variable. Like variable IDs are created every single time we see, any sort of variable in like a function param or an actual user-defined variable. Anything like that gets its own variable ID. So if these are the same, it really is the same T. That really does mean like this T. These would be the same. These would have a different variable. These would have a different variable. Now, if I were doing this up here and being smart, then those would all have the same T and it would probably work. But that would be what we want in that case anyway. So I expected a bunch of red squigglies, but I didn't get any red squigglies. So we need a variable ID. And it looks like these do they reference each other? This is in a unique spot because this is add type. Am I not? I'm pushing this thing into the scope. Am I not creating a variable? We're not creating a variable for these. These will mutually reference each other. But that's okay. We can insert and then mutate. I guess I never needed it. Add variable. Like, what would I need this for? Well, it's not mutable. You can't write to these. Oh, it's because it's a type variable, and I really have only used variable, yeah, for like value land things. Yeah, is mutable. So maybe well, so maybe that's not right. But maybe we can enrich this with something else, like the scope. So T with the same in the same scope is definitely the same T. If it's in a child scope, then it's shadowed and it wouldn't be the same. Does it make sense for a type variable to have a scope ID? I think so. So this t would live in the function scope of new. Yeah. And so then this would be, I don't want to do this first. I want to actually, I'm going to do this first. Scope, the fun scope, fun scope ID. We have it already. And then the other place that we make a type variable is when we make self. So we synthesize the self, the self type variable inside inability definition. So inside the ability scope ID. So inside that ability scope, there's only one self. Yeah, I think this works. Let's go back to dumping module, I guess. So we still have a lot more than one array of t, but that's okay. Do we have less than we had before? So we have 27 total types. Again, this isn't about reducing the number. This is about not having bugs when we intern two type variables to have the same type ID. And then so that things can work correctly because they have the same type ID. Still 27. Can I just that doesn't seem right to me. T1, T2. So when the names are the same, I want to see the scopes. We're doing a lot of these comparisons. 5, 7, 21, 22. Is it because the scopes are very close? So I'm wondering if it's because the function has a scope and the function body also has a scope, so they're not equal. I would want to see the logs for just like one function, which is where turning off the prelude would be nice, but gets a little bit tricky. Okay. So for each of these cases, I'll make scope name. I have a thing that gets a name, like it display scope. It's the thing that powers this. This is the name of a scope. Make. I really thought it was. Let me go to my dump. Scope. Make scope name. Typed module. Is that not accessible from there? That's crazy. Because it's in a submodule of this one. Okay. Self.get scope. Whoops. Scopes. Get scope. T1 not scope ID. This returns a string. Can I do this? Can I dbg inc an argument? That's kind of neat. Yeah, there's a scope for I think there's just one. I need to get rid of logging all the impulse. Impulse. Okay. T1, T2. Okay. Okay, we're rejecting a lot of dupes. I guess they're rarely the same. These all look like cases where the scope being different is what we want. So that's good. So maybe we do only have one. Maybe we already do only have one of these per function. Maybe because I don't refer to that type again by name, like I don't do anything that would cause us to call add type. Like if I were to do, let's, okay. I'm trying to think of a way to refer to. Let me do this. Let me do self. No, I need it in a context where it's array, of t. We're really starting to stretch here. All right. Self array t dot length. Self array t. Self array t. All right. So that should cause us to call evaluate type expression and try to add that type again in this scope. Previously, I just don't think we were trying to add it because I think we just already had it from context. We're just saying, hey, what's a type of self? Great. It's really when we evaluate this expression that we would try to call add type with this, is my theory. So now, with this version, I hope that works. I hope there's no bugs that prevent this from working, and I hope that we still see 27. Eek. Type eek. So what are we on right now? We're on always false. So no. So I hope that we see a lot more than 27. And we don't. So I'm saying type variables are never equal. Oh, yeah. And then I'm saying arrays are only equal if their element types are equal. So let's try to find the log from array push, where t1 well, I think I'm out of time. Still a bit of mystery here as to why these seem to be already getting deduped. Don't like this kind of mystery, so we'll definitely try to figure that out, of course. I think using the scope is the right approach. I think that is what makes a type variable the same as another. Yeah, but we definitely got around our issue with array, and it seems like the approach is going to work, and that's really neat. So we'll have, In my real programs, there will be a lot fewer types in this pool, which is nice as well. Would like to reduce it even more. But yeah, so here types, I wonder if I could like show which scope they appear in or something. That might have a lot of value, but I don't track that. It's not really part of the type either. Anyway, I think that's it for tonight. Not sure if we're really at a good stopping point or if this is something I can commit. I kind of just ran out of time. I guess all tests are passing because we implemented it equals for int and string. So yeah, let's do this. Let's just make sure we slap a big ol' to do. To do, figure out what to do. Bang here. Figure out exactly how to do equality on type variables and test it. Good. Okay, now if I test, I think everything will blow up. Yep. And we'll commit that. So work in progress. Quality based type IDs. Not a great commit message, but that's okay.